It is said that the chemistry of actinides is more complicated as compared to those of lanthanides. Why? So there is the question, why is the chemistry of actinides complicated as compared to lanthanides? And the answer is quite simple, that actinides are the group of 14 elements below the lanthanide series, and the study of actinides is rather complicated because of its radioactive nature as well as the variable oxidation states, which is very common in case of transition metal and actinides also. Then there is another question, complete the following reaction and justify that it is a disproportionation reaction. Of course, the reaction is very simple. 3MnO4, 2 negative, that is 3 times manganate ion plus, of course, in presence of acidic hydrogen, form certain product along with the water. And if we have to complete it, then finally it is completed this way, forms 2 manganate ion, that is manganate ion is converted to permanganate ion. MnO4 2 negative and MnO4 1 negative. 1 negative is permanganate ion and MnO2 is a form, and of course the water is already there. So that's the reaction, and fill up the blanks. If you consider it is 2 MnO4 1 negative and MnO2. Now it is a disproportionation reaction because the oxidation state of manganese as a reactant is +6. But after the reaction, the same manganese atom has two different oxidation states in different species. In permanganate ion, it is +7 and it is +4 in manganese dioxide. So this is the reason for disproportionation reaction. Then we move to the next question, and the question is very important, significant. Given graph shows the trends in melting points of the transition metals. Now let us view the graph. The graph is here, atomic number x-axis against melting point in Kelvin y-axis. And all the three transition series are represented here. And we find here some complication about the melting point of chromium, which is highest first transition series. It has got the highest melting point, whereas that of manganese is lower. So what's the reason? We have to find out. The reason is very simple, that whether it is a melting point or even the boiling point, it all depends upon the metallic bonds between the transition metal elements particularly. And these metallic bonds depend upon the number of unpaired electrons in the transition metal under consideration. Now, if you look at the number of unpaired electron in chromium, that is, we find that the number of unpaired electron in chromium is 6, whereas that in case of manganese, it is 5. So the number of unpaired electron in chromium with configuration AR3D54S1 has maximum number of unpaired electron, and these elements shows high melting point and boiling point. There happens to be an overlapping of the d orbitals and formation of covalent bond during intermetallic bonding formation, metallic bonds. And then what happens that the maximum pairing and bond form. So number of electrons in unpaired electron in chromium is 6, whereas in manganese it has only 5 unpaired electron, which causes its extra stability also, as happens in the case of transition metal. So it is the number of unpaired electron which accounts for strong intermetallic bonding in transition metals. and chromium has got a high melting point as compared to manganese. Manganese has a low melting point as viewed in this graphical representation. And in a way, you find the same thing occurring in second and third transition series also. Okay, these are important points which must be noted carefully and would be helpful to us in answering many questions of different types relating to transition metals. Okay, thank you. Please do not forget to hit the subscribe button. Okay, thank you again.